In this video, we're going to learn about scientific notation, which is a way to write really, really big or really, really small numbers. So we're going to start with a few examples. All right, so first, let's say this true fact that a light year, which is the distance that light can travel in a year, is about 5.88 times 10 to the 12th miles. Okay, now that number is confusing. This is written in scientific notation right here. This is scientific notation. And I want to rewrite it in standard notation. So that means it's going to involve a bunch of zeros, because it's going to be a very large number. All right, so in order to convert, you can just do this math, right? So 10 to the 12th, well, we know that 10 to the 12th will be 10 times 10 times 10 times 10 times 10. We're going to do 12 of them, right? This is 10 to the 12th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now, I could do all that math out, or I could know that each time I multiply by another 10, I'm adding another 0, right? So that gives me this really long number. But then I was supposed to multiply that by 5.88. So we've got 5.88 times, and then this beast, which is 1 with 12 zeros behind it. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And so when I multiply that, well, if we simplify it, if I did 5.88 times 100, that would give me 588, right? And if you just kind of think through that. So that means that this would be 588. That uses up these first three digits, and then I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 left. So this is in standard notation. Now, there's got to be an easier way. The whole point is that we should be able to translate back and forth between these two pretty easily. So I want to show you something. If I took 5.88 and I know it's to the power of 10 to the 12th, if I move my decimal over once, twice, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's where my new decimal is. And then each of those spots in between gets a 0. No decimal there anymore. That is the same number as this guy. I just wrote it weird. Or wrote it out longer. Okay, so our trick is that we're going to move the decimal to the right, the number of that power up there. And scientific notation is always going to be a number times 10 to the power of something. And that number up here is always just going to have one decimal, or one digit in front of the decimal. Okay, let's try it again. So the world population is currently estimated to be about 7.8 times 10 to the 9th. I should say that's in the year 2020. So I want you to try and rewrite that number in standard notation, please. Give it a shot. So hopefully you moved over 1, 2, 3, 4, 5, 6, 7, 8, 9 spots, which means you're filling in 8 zeros because one of those spots was already taken up by that 8 right there. And then we can see that that gives us approximately 7,800,000,000. Now what about small numbers? So another true fact, a nanosecond is about 1 times 10 to the negative 9 seconds. Why negative? Well, think about what we know about negative exponents. 10 to the negative 9, that's the same as 1 over 10 to the 9th, right? Hopefully I've drilled that through your brain really, really good by now. Well, that's going to be the same as 1 over, and then 10 to the 9th. I know that's a billion because we just did it on the last one. So we're going to have 1, and then we're going to have our 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, well, that is the same as this decimal right here, which we know because if the 1 were right here, that would be a 10th. So then this one would be the 100th place, the 1000th place, the 10,000th place, the 100,000th place, the millionth place, on out to the billionth place. Now notice this is not actually 9 zeros, this is 8 zeros. Okay, and that's because the 1 or the 10th place doesn't get a 0, right? So everything's like minus 1. But fortunately, you don't actually have to remember that. You just have to remember the shortcut, which is exactly the same as the other one, except now we're going the other direction. Okay, so if I had 1, and then I'm doing 1 times this, which is obviously just that, right? Because it's just a 1 there for this specific problem. But normally what you would do is you would take the 1, and then I know it's going to be to the negative 9, so I put the decimal in where it starts, which is right there, and then now I have to go backwards. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I put my decimal there, I fill in my zeros, and that gives me 8 zeros before the 1 because I had to use up one of them getting to the other side. Okay, so here we are in standard notation. This is scientific, this is standard. Scientific. Okay, let's do another one. Let's do an easier one this time. Let's say that actually we're gonna, no, we'll do another one that's big like that. So a water molecule is 2.78 times 10 to the negative 10 meters wide. I want you to convert that into standard notation, please. So this one, they give us the decimal to start with. So, but remember, this is a negative, so we're going small numbers. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to fill in all those zeros. 1 for each little bump. That is a small number. Now, what if we were going the other way? Let's say I give you a number and I want you to write it in scientific notation. So, actually let's do brief notes on this first. So, to write in scientific notation, SciNote, you are going to have 1 digit before the decimal place, and then however many digits after you want, and then times 10 to the power of something. So this number right here only have one number, and it can't be a 0, one non-zero number before the decimal. One non-zero number before the decimal. Okay, so let's take an example of, I believe this was the weight of a grain of sand, was 0.011 grams. It's a small one. So in order to write it in scientific notation, we need to rewrite this number so it has one digit, one non-zero digit before the decimal. So that means I have to move it over 2 spots. If I move it over 1, it's a 0 before the decimal. If I move it over 3, there's an 11 before the decimal. I want to just have one digit before the decimal. So that means I write 1.1, and then I counted. I moved it twice, times 10, and then it's a -2 because it was a small number that I'm making bigger. 1.1 times 10 to the 2. All right, now we're going to try it again, writing it into scientific notation. Google tells me, Google's an amazing thing, there are about 3,500,000,000,000,000 fish in the sea, according to estimates of people who know about these things. I want you to write that number in scientific notation, please. So to do this, we have to figure out where the decimal starts, right, which will be right at the end. And then I need to move it all the way over. So I can draw it all the way out. I can also just kind of count it 3, 6, 9, 12. So to end up here, and I've moved 12 spots over. So that would be 3.5 times 10 to the 12th. All right, for your practice problem today, you get to explore the joys of Google. I want you to find a fact that I could have used in this video that uses a very small or a very large number. You get to decide how you define very small or very large. And I want you to write it in both scientific notation and standard notation. Type your fact in with both forms as your submission for this assignment.